Chapter 3 of the M1 Mechanics textbook, exercise 3B, page 45, the challenge question at the end of the exercise. This is from the new mechanics textbook, the new M1 textbook. This is the chapter vectors in mechanics, sorry. And the challenge question is as follows. Given that A equals 3i minus 5j and B equals I plus 4j, find the values of lambda if A plus lambda B is perpendicular to 3i minus 2j. Okay, so we got A equals 3i minus 5j and B equals I plus 4j. Find the values of lambda if A plus lambda B. So first of all, let's work out what A plus lambda B is. A plus lambda B is equal to. Now we know the vector A is 3i minus 5j. So I like to use column vectors. So I'll just put that's 3i and minus 5j. And the vector B is I plus 4j. So that's I plus 4j. So that's I, and that's the j component, so I plus 4j. Column vectors are normally easy to deal with when you are using arithmetic with them. So now, A plus lambda B would be 3 minus 5 plus lambda times 1, 4, which gives you 3 plus lambda, so that's the I component, the horizontal component, and minus 5 plus 4 lambda. Okay, now this vector is perpendicular to 3i minus 2j. Now when two vectors are parallel, you can say one of the vectors is equal to some multiple of the other vector. Okay, but perpendicular, this is why this is a challenge question, it's slightly different. Now there is a method that you will learn when you do P3, okay, if you go on to doing A-level, A2 maths, where you can work out a relationship between two vectors if they are perpendicular to each other. But that's not really what's required here, because we're still on, this is just M1, so they're just trying to test your understanding about lines which are perpendicular and parallel. So I'm going to teach you from a different perspective rather than teach you this other method which has to go into other details. I'm just gonna teach you from the things that you already know, and you'll be able to work out the answer. So we know that if this vector is perpendicular to that vector, then it's parallel to the vector that is perpendicular to this vector. Okay? Any vector that's perpendicular to this vector will be parallel to this vector. Okay? So we know that A plus lambda B is perpendicular to 3i minus 2j. Therefore, it will be parallel to the vector perpendicular to this. So let's find the vector that's perpendicular to this vector. Okay, so you have 3i minus 2j. Now, I want you to try to picture what that looks like. If you start from here, 1, 2, 3, horizontally, and 1, 2, vertically down. Okay, so this is like a sketch of the vector 3i minus 2j. Okay, it's going in this direction. That's a sketch of that vector. Okay, it's just, alright, so that's 3 units horizontally across and 2 units down. Okay, now we know something about parallel lines and perpendicular lines from the perspective of straight line graphs. We learned about straight line graphs. We dealt with parallel lines and perpendicular lines, and we learned that the gradient of two lines, the gradients of two lines that are perpendicular, their product is -1, or we could say one of the gradients is the negative reciprocal of the other gradient. Okay, so I'm going to think about this vector in terms of its gradient. Now the gradient is the change in y, change in the vertical displacement over the change in x. So the gradient of this line is going to be -2 over 3. Okay, -2 over 3. Okay, it's going 2 down and 3 to the right. Okay, so the gradient of a line that's perpendicular to this line will be the negative reciprocal, will be -3 over 2. Okay, so for a line, the negative reciprocal So it will be positive 3 over 2, sorry. Okay? So the gradient of a line that's perpendicular to this line will be 3 over 2, the negative reciprocal. So let's say we're starting from, and it doesn't matter where we start from, but let's say we start from a point here. Now, that's the gradient. That translates as a vector. Remember, this is the vertical displacement, this is the horizontal displacement. In vectors, the top number is the x value, the horizontal displacement. This would translate as a vector as 2, 3. Okay? So say we're starting here, we've got to go 2 to the right and 3 up. 1, 2, 3. So it'll look something like this. Okay? So this will be the vector which is perpendicular to that vector. Okay? So that's the vector that's perpendicular to this vector. It's the vector 2, 3. However, there's another case as well. Supposing this vector is going in the opposite direction. That vector is also the same. Okay, it's also perpendicular to this vector, but it's just going in the opposite direction. It's still perpendicular. So there's 2 vectors that you could say are perpendicular to this one vector, which is 2, 3, and it's just the opposite of that, which is minus 2, minus 3. So let's take each case. Let's take the vector 2, 3. Okay, and let's see if what we can determine. So I know that the vector a plus lambda b is definitely equal to some multiple times 2, 3. Okay, a plus lambda b is definitely parallel now to this vector 2, 3, so it's equal to some multiple of it. So I'll call the multiple k. Alright, so a plus lambda b is some multiple of 2, 3. So we can say that 3 plus lambda and minus 5 plus 4 lambda is equal to, you can say 2k and 3k. Okay, so we have here now a pair of simultaneous equations which you can solve. We can say 3 plus lambda is equal to 2k and minus 5 plus 4 lambda is equal to 3k. Now they ask us to find what lambda is, so let's multiply this by 3 and multiply this by 2, thereby we'll eliminate the case. So you have 9 plus 3 lambda, 9 plus 3 lambda is equal to 6k, and minus 10 plus 8 lambda is equal to 6k, and then we can just subtract these vectors to get rid of the k's. Let's subtract this way. We'll have 6k minus 6k is 0, 8 lambda minus 3 lambda is plus 5 lambda, and minus 10 minus 9 is minus 19, so we're left with 5 lambda is equal to negative 19, so lambda is equal to negative 19, sorry, silly mistake there, you have to add 19 to both sides, so lambda is equal to 19 over 5. So there's our value for lambda. Now, there's possibly another value for lambda, okay, because we said there's also the case when we have the vector minus 2 and minus 3. So let's look at that case. In that case, we'll have 3 plus lambda and minus 5 plus 4 lambda is equal to, instead of 2, 3, this will be minus 2 and minus 3, so you'll end up with minus 2k and minus 3k. Okay, so we can now again look at the I components. They must be the same. So 3 plus lambda is equal to minus 2k, and minus 5 plus 4 lambda is equal to minus 3k. Let me just tidy that up. Minus 5 plus 4 lambda is equal to minus 3k. If we multiply this by by 3 and this by 2, we'll end up with 9 plus lambda equals minus 2k and equals minus 6k, and we'll have minus 10 plus 8 lambda equals minus 6k. again, we'll get exactly the same answer because you've got exactly the same things. You just subtract these. When you subtract them, they have the same sign of -6 minus -6, which is 0. And this should be, sorry, that should be 3 lambda here, sorry. 9 plus 3 lambda, sorry. Okay, so 8 lambda minus 3 lambda is 5 lambda. Okay, and you have minus 10 minus 9, which is minus 19 lambda. You see minus 19, sorry. So you see you get exactly the same thing. So 5 lambda is equal to 19. So lambda is equal to 19 over 5. So the question does state, all right, that given that a equals this and b equals that, find the values of lambda. Okay, so if a plus lambda b is perpendicular to that, comment on your answer. So basically we see that our answer for lambda, okay, is the same answer in both cases. Whether it's going in one direction or it's going the other direction, our value for lambda will be exactly the same. Okay, and you do notice they said values, so there's more than one value you can find. However, those two values, those more than one, they're both the same in either case. So that's what they're intending here. They're intending that one of the vectors is going in one direction, which is perpendicular to that vector, and the other one is also perpendicular to that vector, but it's going in the opposite direction. Okay, those two vectors, okay, will be parallel to a vector which is perpendicular to this vector. Okay, so basically what we did was, normally we're used to seeing a question that says a plus lambda d is parallel to such and such a vector. So you say a plus lambda b is equal to k times that vector. But in this case, a plus lambda b is perpendicular to a particular vector. So we can say a plus lambda b is equal to k times a vector that is perpendicular to this vector. So we have to work out what vector is perpendicular to this. And we can see that from the gradients as we did. Okay, so there's the end of that question.